Hey guys, what I wanted to talk to you about in this video is what we're going to focus on for most of this coming week. This sort of math mission is a little bit lengthy and might sound a little bit complex, but I just want to give you an intro now and then we can discuss more in class this coming week. I hope you all enjoyed your Halloween or having a good weekend. Um, the math mission here is I can use what I know about shifting graphs to graph absolute value functions and derive absolute value functions from their graphs. So it's a lot of sort of going from equations to graphs, from graphs to equations, and thinking about what we know about different parts of an equation like slope and shifting a graph up or down with the y-intercept, or how changing the input can move a graph left or right. Applying that to absolute value functions. Now, a lot of you, I know, already know what absolute value is, but just in case we might need a refresher, absolute value is defined as the distance from 0. And absolute value is always positive because distance is always positive. If you got in your car, you never drive -2 miles. You always drive 2 miles, regardless of the direction you're going. So, for example, the absolute value of 5, these two bars mean absolute value, so this means the absolute value of 5 is 5, because 5 is 1, 2, 3, 4, 5 spaces from 0. The absolute value of -5 is also 5, because -5 is 1, 2, 3, 4, 5 spaces, or 5 units from 0. So again, absolute value is distance from 0, and the absolute value of 5 would be 5. The absolute value of -5 would also be 5 because of that definition. So in general, the question would be, what do absolute value graphs look like? Absolute value is it can be very complex. There's some really interesting problems we can think about with absolute value, but my focus here is to, again, go from an equation to a graph and a graph back to an equation. So let's just sort of examine this with sort of a set of x values that we could plug in as inputs to this equation. F of x equals the absolute value of x. So if we took our -2 and we plugged it in for x, well, that means the output, the f of x, would be the absolute value of -2. And based on our definition of absolute value, we know that would give an output of 2. We could think about, all right, well, if the input is -2 and the output is 2, that could be like the point -2, comma 2, and you see that green dot show up right there. Similarly, if we plugged in -1 as an input, well, the output there, the absolute value of -1, would be 1. And we see another point at -1, comma 1 show up. We could keep going, just plugging in these values for the input. So it'd be like absolute value of 0, which would give us 0 coming out, absolute value of 1, which would be 1 coming out, absolute value of 2, which would give us 2 coming out. And we see that these points are sort of creating this V-shaped graph, with one line sort of heading out that way, another line heading out that way. So these are just 5 points, but in fact, if we were to do this and plug in every single possible x value, you would see that the absolute value of x, the graph of that, looks like a V, where the line sort of continues on up to the left forever, and on the right side of the graph it continues on up to the right forever. So in general, all graphs, or all equations rather, that have an absolute value in them will be a V like this. And you can imagine that just like we can change the slope or the y-intercept of a line, we could change the slope of these two sides of the V, we could change the y-intercept of the V, depending on what we do, right? So this graph, for example, is sort of a shift of that graph we saw before. This one is the graph of f of x equals the absolute value of x minus 2 plus 3, right? And we could sort of imagine sort of based on what we talked about when you add to an entire function or when you subtract or add just from the input, and we'll talk about this more next week. But in this case, so we saw before that the absolute value of x just had this v centered at the origin, centered at 0, 0. But then if we subtracted 2 from the input, well, when you subtract from the input, you move the graph to the right, and you can see that this v is sort of from 0, it's moved 1, 2 to the right, and the plus 3 sort of means it's moved 1, 2, 3 up, because that's a 3 added to the entire function. So again, we subtracted 2 from the input, which means it was moved 2 to the right, and added 3 to the entire function, then means it's moved 3 up. So we have that same sort of sloped v, just moved 2 to the right and 3 up. So focusing on an equation like this and being able to shift it around is what we're going to talk about this week. If you have questions, please do write them down and we'll discuss in class. Enjoy the rest of your weekend, and I will see you on Monday. Thanks.